Okay, in this lesson we're going to look at proving identity number 9 from our list of trigonometric identities in our course. And identity 9 says that tan of a plus b is equal to tan of a plus tan b all over 1 subtract tan a tan b. So things you need to know in order to be able to prove this: you need to know identities 5 and 7, which we've proven in a previous class. Cosine of the sum of two angles, sine of the sum of two angles. You need to know the tan identity, which says tan of any angle is sine of that angle divided by cosine of that angle. And you need to know what a multiplicative identity is. And all it is this: if I divide or multiply the top and bottom of a fraction by the same quantity, then the value of that fraction remains unchanged. So for example, if I have the fraction 8 over 6, if I divide the top of that fraction by 2, but I also divide the bottom of that fraction by 2, well then the fraction remains unchanged. Okay? Of course, multiplying by the same number, top and bottom, for example, multiplying top and bottom by 10, will give me an equivalent fraction as well. So multiplying or dividing the top and the bottom of the fraction by the same quantity, the value of that fraction remains unchanged. So with those three things, in our pocket, we're going to go and prove identity number 9. So we're going to prove this. We're going to start just by looking at, first of all, the tan identity, which says tan of this angle a plus b will equal to sine of a plus b divided by cosine of a plus b. Okay, that's my tan identity. So that's an identity we've proven before. Identity 5 and 7. Now we know that sine of a plus b, that's identity number 7. We've proven it in a previous class, is sine a cosine b plus cosine of a times sine of b. And on the bottom of that fraction, cosine of a plus b, well, that's identity number 5, again, which we've proved before. That's cosine of a times cosine of b, subtract sine of a multiplied by sine of b. Okay, so that's what we have so far. We're able to say tan of a plus b is equal to this thing. The next thing I'm going to do is I'm going to use the multiplicative identity, and I'm going to divide top and bottom of this fraction. What am I going to do? I'm going to divide top and bottom of the fraction by cosine a cosine b. And that's really the trick. Okay, we're dividing top and bottom of this fraction by cosine a cosine b. And that division has to distribute. We have to divide, each term in here by cosine a cosine b. That's what we're doing. We're distributing this across. So dividing the first term, sine a cosine b. Well, let me write it out explicitly here. Sine a times cosine of b, and I'm dividing that by cosine of a cosine b. Also, the second term on the top here, we'll have cosine of a times sine of b, and I'm dividing that. Remember, I have to divide each term on the top by cosine of a cosine of b. That's my top, that's my numerator. On the bottom, I'm dividing this first term here by cosine a cosine b, so I'm getting cosine a cosine b divided by cosine a cosine b. And then we have a subtraction, and I divide the second term here, sine of a times sine of b divided by cosine of a cosine of b. And we're nearly there now. It's just a question of some fairly straightforward kind of cancelling, I suppose, and using the tan identity again. So a couple of things to note here in this first fraction on the top: cosine of b's will cancel. In this second fraction on the top, the cosine of a's will cancel. Over here, cosine a cosine b over cosine a cosine b, well, anything divided by itself is 1. And in this last one here, sine a over cosine a, sine b over cosine b. Well, we know some stuff about sine over cosine. So if we look at each of these here, in this first fraction we've got sine of A divided by cosine of A. My tan identity tells me that's the same as tan of A. Then we have plus sine of B divided by cosine of B. We know from our tan identity that's the same as tan of B. Here we have cos A, cos B divided by itself, so that's just 1. And then we have subtract, well, sine A over cosine A is tan A, times sine B over cosine B, that's tan B. So we've got tan of A plus B is equal to that. And that is the proof of identity number 9. So go through the steps again. The first thing we use is the tan identity to write the sum of the angles as sine over cosine. And then it's this kind of a bit of a rabbit out of a hat, I suppose. You've got to remember this. And I always remember it's cosine A, cosine B, because we want to get a 1 down here. What do we divide this term here by to get a 1? Well, we divide it by itself. And remember, it's a multiplicative identity. I'm dividing the top and the bottom by the same number, so this fraction is equal to this fraction, and those equal signs are important. So that's the proof of identity number 9. 1, 2, 3, 4 very simple steps, but you got to know what's come before. Okay, your tan identity, identity 5, identity 7, and multiplicative identities. Okay,